Hi guys, my name is Shubhang Garodia, Chemistry Master Teacher at Vedantu. Today we are going to talk about JEE Advanced 2020 Paper 2 and question number 16. Now, it's a numeric type question, so be careful of calculations, be as accurate as you can. Consider the reaction sequence from P to Q shown below. The overall yield of the major product of Q from P is given to us. What is the amount in grams of Q obtained from this much ml of P, and there is some data given. Now, we also have some organic reaction given to us so that we can find Q. Okay, let's first come to our question. He says that P to Q, the yield here is 75%. Then he says, I have 9.3 ml of P. Okay, and then density of P is also given to us. Density of P is 1 gram per ml. What does this mean, guys? This means that the weight of P given to us is 9.3 gram. Okay, now what is P? P is aniline given to us. So let's calculate molecular weight of P. Molecular weight of P, when you will calculate, will come out to be 93 gram per mole. How did we get 93 gram per mole? As you can see, there are 6 carbons in aniline, right? There is 1 nitrogen in aniline, and how many hydrogens? We have 5 hydrogens in the ring and 2 hydrogens outside. So 7 into 1, when you total it up, it will come out to be 93. Okay. Now what does this tell us? This tells us that the moles of P given to us are 9.3 by 93, that's 0.1 moles. Okay. Now question says, the overall yield of major product Q from P is 75%. That means number of moles of Q will be how much? Number of moles of Q, will it be equal to directly 0.1 into 0.075? Will this be the answer direct? Before we go to this, sorry, into 0.7, yeah. Before we go to this, we have to first check that what is the reaction happening here. So let's go ahead and try and figure out the reaction first. Now, we have been given aniline, and the first step, as we all know, is diazotization, in which PHN2 plus will be formed. Because low temperature is given, this will be formed as an intermediate here. Now, this species is given as to react with alkaline beta naphthol. Okay. Now, beta naphthol pe PHN2 plus will attach and give us red dye. Remember, azo dye formation. So first we have to figure out at what position in beta naphthol do I attach PHN2 plus. Okay. Now, this is your general structure of beta naphthol. So there are two possible positions. Because OH is a plus M group, it will activate its ortho as well as para. So there are two possible positions. Let us call this position A and let us call this position B. Now, the electrophile, incoming electrophile, can attack at A as well as B. So let me show you what happens if it attacks at A. If the incoming electrophile attacks at A, we will have an electrophile attached here, OH attached here. The positive charge will come here and pi bond will be here. As you can see, the second ring is still a benzenoid type structure. Even if I resonate this positive charge once, even twice, it still remains a benzenoid structure. Now, if we do that for B, let's do that. Let's attach electrophile at B position. We get a carbocation here. Now, the moment I resonate it, the benzenoid nature of rings is lost. Let's check that. Let me show you that. The moment I resonate it, I bring the positive charge here. Pi bond comes here. There's already a pi bond here. As you can see, the benzenoid nature of the ring is lost. Even if the pi bond resonates ahead further, the second ring, the left ring, is still a non-benzenoid ring. Okay, it is still a non-benzenoid ring. And therefore, guys, we always prefer in alkaline beta naphthol electrophile coming and attaching to a left, that is A position. Okay. Let me take it ahead from here. So therefore, we have understood that PHN2 plus will come and attach where? Will attach here. Okay. Let's go back to our question. And the last step was acidification with water. Acidification with water essentially just gets rid of the cations present in the system, mild acidification. So this is your final answer. This is your product, that is Q. So as we saw, 1 mole of PHNH2 gives us 1 mole of PHN2 plus, and therefore this gives us 1 mole of red dye. Okay. So 1 is to 1 is to 1. Therefore, if you remember on one of the previous slide solutions, we said that is it correct to say that 0.1 mole of P should give 0.1 mole of Q, and therefore we use it 75%? Absolutely. This reaction sequence tells us that if I take 1 mole of this, the product form should be 1 mole. I have been given 0.1 mole of the reactants. So with 100% yield, the product form should be 0.1. But we know that this is not 100%. We know that the yield given is 75%. So how much of product will be formed? Reactant ka 75%. Right? So therefore, number of moles of Q formed is 0.1 into 75 by 100, right? That's 0.075. And let's convert this into weight of Q so as to get the answer. 0.075 into 248 gram per mole, that is the molecular weight of this compound. And hence, guys, our final answer is 18.6 grams. Okay. So final answer is 18.6. Thank you so much for joining us, guys, and stay tuned for our next question.